Hello children, today we will start with very important chapter of class 10th, trigonometry. Trigonometry is a special branch of mathematics that deals with the measurement of three angles of a triangle. As the name suggests, trigonometry, it is derived from a Greek word, a combination of two words, trigonon, that means triangle or three angles, and metry means measurement. So it gave us information regarding the measurement of three angles of a triangle. So our mathematician, they took an angle and dropped the perpendicular at different places, and they observe that whenever they are taking the ratio of the two sides, suppose they are taking the ratio of perpendicular and base, any two sides they have taken. So if they have taken the ratio of perpendicular and base at different places, they find that every time they are getting the same ratio. Similarly, they have experimented it by taking any two sides and framing the ratio. They are getting the same value at all the places. So what they did is they tried to make all possible ratio out of three sides of a right angle triangle. You all know children that the three sides of the triangle are always of a right angle triangle are always represented by perpendicular, base and hypot. So let's try making the different ratios by taking any two sides. So if I am taking perpendicular in the numerator first, then dividing it by base, I will get perpendicular upon base. Or if I take perpendicular in the numerator and dividing it by hypot, so I will be getting perpendicular upon hypot. Similarly, if I will take base in the numerator and perpendicular in the denominator, or I may take base in numerator and hypot in the denominator. Similarly, I can take hypot in the numerator and perpendicular in the denominator, or I may take hypot in the numerator and base in the denominator. So in this way, we are able to create three ratios by taking different sides of the triangle. Then comes how to distinguish these three ratios. So they gave them different names, and the names are sine theta is equal to perpendicular upon hypot. Then cos theta is given by base upon hypot, and tan theta is given by perpendicular upon base, and their reciprocals are represented by cosec theta, sec theta or cot theta. So children, if you are taking the reciprocal of sine theta, that means the ratio will be hypot upon perpendicular. So that is represented by cosec theta. Cosec theta represented by hypot upon perpendicular. And sec theta is the reciprocal of cos, represented by hypot upon base, and tan theta, the reciprocal of tan theta, is represented by cot theta, and which will be base upon perpendicular. Representing theta is compulsory part here. Writing theta with sine, cos, tan, cosec, sec and cot is compulsory here. Theta means any angle. Since if you take angle equal to 45 degree, the measurement of these two sides will be different. Therefore, the value of the ratio will be different. And if you take theta is equal to 45 degree, then the measurement of these sides will be different, and therefore the ratio will have different value. So this theta is the mandatory part where we will put the value of the angle. Now children, with this you have observed that sine theta is equal to 1 upon cosec theta, or you may say cosec theta is equal to 1 upon sine theta. Then cos theta is equal to 1 upon sec theta, or you may say that this is equal to sec theta equal to 1 upon cos theta, or you may say that cot theta is tan theta is equal to 1 upon cot theta, or cot theta is equal to 1 upon tan theta. So we will have 6 relations here between these trigonometric ratio. All these 6 ratios are also known as trigonometric ratio. Now children, we will take a right angle triangle and try to understand the concept related, and will help you understand the trigonometry and apply the trigonometry better. So this trigonometry is always applicable in a right angle triangle, and when you draw a right angle triangle, then you will have two acute angles, and these two acute angles are either this one or this one. So let us consider one at a time. So the angle that I am considering, I'll be calling it as theta. And let's name the triangle A, B, and C. Always the side opposite to theta that you have considered, if you are considering this acute angle, then the side opposite to this is also known as opposite side, or is known as perpendicular. And the side opposite to right angle is always taken as hypot, and the rest is the base of the triangle. So children, if I want you to write down sine theta, you will write for this particular triangle, sine theta is equal to perpendicular upon hypot. So it will be equal to AB upon AC. Or if you are writing cos theta, you will write base upon hypot. Therefore, it will be BC upon AC. Or if you are writing tan theta, which is equal to perpendicular upon base, so you may give AB upon BC. Similarly, you can write the other three trigonometric ratios also. I hope you are able to understand this thing. Now children, let's start with the exercise 8.1. Exercise 8.1. And let's do question number 3. In this question number 3, he is giving you sine A is equal to 3 by 4. And he wants us to calculate all trigonometric ratio. So if you want to do that, children, you will first make a triangle. So let's draw a right angle triangle. And since always here we take acute angle, and here it is written sine A, that means the acute angle that you are considering should be named as A. That's why I am naming A here at the acute angle. And this will be 90 degree. And this will be taken as B and C. Now, if sine theta, sine A is given equal to 3 by 4, we all know the formula. Sine A is perpendicular upon hypot. This implies that sine perpendicular can be taken as 3, and since it is a ratio, so common part will cancel each other. Therefore, perpendicular is equal to 3x. You may take 3x. So when we are talking about ratio, we may call it as 3x also. And hypot is equal to 4x. So children, this will be 3x. Perpendicular is 3x and hypot is 4x. You all know Pythagoras theorem. Using that, you are able to get the missing side. So by Pythagoras theorem, we have that hypot square is always equal to perpendicular square plus base square. So 16x square is equal to 9x square plus base square. That means base will be equal to 7x square Therefore, base is equal to square root 7x. Now we have all the three sides of the triangle and we need to calculate all the trigonometric ratio. So that means cos theta is equal to, or we may say cos A is equal to base upon hypot. Base you have already calculated, that is square root 7x. So this is square root 7x upon hypot is 4x. So children, you have seen, since you are getting the ratio, so this x and this x will cancel each other. That means you will get square root 7 by 4. So you have seen, since we are finding all the ratios, so every time this x and this x will cancel. So there is no need of writing x again and again. We may write directly that tan theta, tan A is equal to perpendicular upon base. Perpendicular is 3 and base is square root 7. So the value of tan theta is equal to 3 square root 7. 3 upon square root 7. Now we want to find out the reciprocal of these trigonometric ratios. Reciprocal of sine is cosec. Cosec A will become, sine A is 3 by 4. So cosec A will become 4 upon 3. The reciprocal of cos A is sec A. Therefore, this will be 4 upon square root 7. And the reciprocal of tan A is cot A. Therefore, this will become square root 7 upon 3. So in this way, we are able to calculate all the trigonometric ratios if we are given only one. So here you have learned that since you are calculating all the trigonometric ratios, there is no need to put x in further questions. I will be writing directly that perpendicular is 3 and hypot is 4. Now let's do question number 7 of the exercise 8.1. In question number 7, we are given that cot theta is equal to 7 by 8, and he wants us to calculate the value of 1 plus sine theta upon into 1 minus sine theta upon 1 plus cos theta into 1 minus cos theta. Children, this question can be done in 2-3 manners, but since you are a beginner, so you will be starting with whatever you are easily able to notice here. So first of all, you have seen in one bracket you are able to see 1 plus sine theta, 1 minus sine theta. So applying the identity a plus b in one bracket multiplied by a minus b in the other bracket, I'll able to write this as 1 minus sine square theta. And in the denominator, if I apply the same identity, I can write 1 minus cos square theta. Now let's see what is given to us. We are given cot theta is equal to 7 by 8. If we are given cot theta is equal to 7 by 8, that means cot theta is base upon perpendicular. So we may take base as 7 and perpendicular as 8. By applying Pythagoras theorem, hypotenuse square is equal to perpendicular square plus base square. So this is 64 plus 49 will give you 113. Therefore, hypot is equal to square root of 113. If you know this, then that means you are able to get the value of sine theta, which is perpendicular upon hypot. So this implies that sine theta is equal to 8 upon under the root 113. Similarly, cos theta is equal to base upon hypot. Base is 7 and hypot is square root of 113. Putting the values that you got here in this. So this is 1 minus, in place of sine square theta, I will put its value. This is 8 upon square root of 113 whole square upon 1 minus 7 upon square root of 113 whole square. So this will become 1 minus 64 upon 113 and 1 minus 49 upon 113. Simplify it further, you will get 113, then 113 minus 64, and in the denominator you will get 113 and this will be 113 minus 49. So this and this can be cancelled and you will be getting, so the answer is 49 upon 64.